The next example, which will give an overall conceptual aspect of polynomials, speed calculator. So let's design a calculator which gives you speed given the distance and time. The first thing is we will talk about formula. So when it comes to formula, it's quite simple. We have this. We have speed is equal to what? Yes, distance divided by time. Is it not? Speed is equal to distance by time. Now, if I want to represent this in equation form, okay, so we have speed denoted by S, distance by d, and time by t. We have this, but yes, we need to write in this way, indicating that speed is dependent on distance and time, right? It is read as S of d comma t. What does it mean? It means that speed is dependent on distance and time. So distance and time are independent variable while speed is your dependent variable in this particular case. So we didn't do any research, we didn't do any analysis, we didn't look at any scenario. It was a straightforward, simple speed calculator because it's already well established that speed is equal to distance by time. So we didn't do any research. We already have the formula. So the research part went away. We directly wrote the formula, statement form, and then equation form. And well, we are trying to understand it a bit more. So let's code it. So obviously I've coded it before itself. And now let's execute it, calculating the speed given the distance and time. So let's execute this. So please enter the distance in meters. So we have, like say 30 meter being covered in 2 seconds. And the distance is, oh, I have to change the cost is, the speed is, sorry. Speed is, okay, let's redo that. We have distance with 30, time is 2 seconds, and we have 15 meter per second. Makes sense, right? So where is that particular aspect that we need to concentrate on? Here, the function which helps us to calculate speed. So you can clearly see speed is dependent on distance and time variable. So in here we are calculating distance divided by time, right? So let me show it. Yeah. So here we are calculating distance by time. So that's what the machine is doing. So the machine is taking not 1, actually 2. Okay, it's taking 2 inputs, distance and another is time. So once that is calculated, we get a output called speed. Okay, so here your inputs are distance and time and your output is speed, right? So there are different distance and time that we have been given, and we have to find the respective values. Values are nothing but output for a specific input. So we have distance and time to be 30 and 10. So let's have a look. Distance is 30, time is 10, the speed is 3 meter per second. So the value of this input is 3 meter per second. Next is 430 and 12. So person is covering 430 meters in 12 seconds. So we have 35.83, an approximate value 37.83 meter per second. Next is we have one of 1440 into 10 to the power of 8, and the time is 480. So 1440 followed by 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, and the time is 480. 480, and we have 3 followed by, let me copy that, so we have 1, 2, 3, 4, 5, 6, 7, 8. So 3 into 10 to the power of 8 meter per second. You recognize this value? This is the speed of, yes, light. Okay, so actually this values, right? These values are nothing but distance between the Earth and the Sun, and this is the number of seconds it takes, not some. Not that Sun also. Yeah. So this is the time that it takes in seconds for it to reach us. It's around 8 minutes. So I knew the time, approximate time. Of course, I knew the speed of light, approximate again this too, and we found I found an approximate distance, and I have put it over here. So we can see that the machine that we have designed is able to calculate the speed for any given scenarios. Right? Well done.